Alright, so today we're going to be doing a pretty straightforward optimization problem involving calculus. So without further ado, let's get started. So a garbage can is in the shape of a cylinder with no lid. So let's draw a garbage can. It's in the shape of a cylinder. And it states it has no lid. And it must have a volume of 5,000 centimeters cubed. So our volume must equal 5,000 centimeters cubed. Find the dimensions that would use the least amount of material to construct this garbage can. So what would those dimensions be? Well, our height and our radius. I mean, I guess we could use our diameter, but it would just complicate this question. All right, so let's start with step one. And step one and step two are going to be co-aligned with each other, meaning we're going to be doing them roughly around the same time. So I'm also going to write step two. So step one, what is the volume? What is the formula of the volume of a cylinder? Well, volume is equal to pi r squared times the height. And what is our volume? Well, if you look here, it is 5,000 centimeters cubed. So 5,000 is equal to pi r squared h. All right, step two. What is the formula of the surface area of a cylinder? Well, surface area, so just write surface area is equal to 2 pi r times the height plus 2 pi r squared. And what do we notice about this specific cylinder, or in this case, garbage can? Well, there's no lid. So if you notice this part of the equation, what does that represent? Well, this 2 pi r squared represents this circle, right? Pi r squared, and this circle. But because there is no this circle, we can get rid of that 2 and turn it into a 1. So our surface area is equal to 2 pi r times the height plus pi r squared. So now what? Well, we want to get our surface area as a function of one variable. And in this case, there are two variables. And what are they? They're our radius and our height. So how are we going to get our surface area in terms of one variable? Well, we get that from our volume equation, right? And in this instance, I think it's better to get our surface area as a function of radius. Why? Well, if we go back to our volume equation, if we want to isolate for the radius, we'd have to divide both sides by h and pi and then square root. That's just a little bit too much work. So instead, we can just isolate for h. And how are we going to do that? Well, h is equal to pi r squared. Sorry, h is equal to 5,000 over pi r squared, right? We just divide both sides by pi r squared. It's as simple as that. All right, so now we finally have our surface area as a function of one variable, that being our radius. And what do I mean by that? Well, surface area is equal to 2 pi r times what I say h was. Well, h is 5,000 over pi r squared. So 2 pi r times 5,000 over pi r squared plus pi r squared. So as you can see, our entire function is written in terms of one variable, that being our radius. And don't get confused with our pi as a variable, as that is just a number, technically, 3.14. And now we can do a little bit of simplifying. So our surface area as a function of r is equal to, well, we can cancel out this pi r and this pi r to give us r to the 1, which is just 1. And we can multiply this 2 by this 5,000 to give us 10,000. So 10,000 over our radius, over r, plus pi r squared. We can leave it like this, but for our next step, I think it'd be a lot easier to move the r and turn it into a negative exponent. So how are we going to do that? Well, surface area as a function of r is equal to 10,000 times r to the negative 1 plus pi r squared. And why did I do that? Well, if you read the question, it says find the dimensions that would use the least or minimum amount of material to construct this garbage can. And how are we going to find the least or the minimum? Well, how do we find the minimum of a function? Well, we can set the first derivative equal to 0. And that is why I turn this into r to the negative 1 instead of having 10,000 divided by r, right? Because that, if we did this way, we'd have to use the quotient rule. But through r to the negative 1, we can just use our product rule, which is far easier than the quotient rule. So, step 3, we set our first derivative equal to 0. But before we can do that, obviously, we have to solve our first derivative. So, surface area prime of r, that just means our first derivative is equal to, well, negative 1 times 10,000, so negative 10,000 r to the negative 2 plus 2 pi r. And we can simplify this a little more. So surface area of the function of r is equal to negative 10,000 over r squared plus 2 pi r. All right, so now we can finally set it equal to 0. So 0 is equal to negative 10,000 over r squared plus 2 pi r. So move the 2 pi r to the left, so negative 2 pi r is equal to negative 10,000 over r squared. And we can multiply both sides by r squared to cancel out this r squared at the bottom. So negative 2 pi r cubed is equal to negative 10,000. And now we can divide both sides by negative 2 pi to isolate for r. So r cubed is equal to negative 10,000 divided by negative 2 pi. And a negative divided by negative, well, that's just a positive. So positive 10,000 divided by 2 pi. And how are we going to get rid of this r to the third? Well, we can cube root it. But I know that a lot of you guys probably don't have the cube root function on your calculator. So instead, we can just multiply by a third, right? Because that's the same thing as cube rooting. So times a third. So multiply both sides by a third. So r is equal to 10,000 over 2 pi times 1/3. And if you plug that into your calculator, you should get a value of approximately 11.7. And because we're using centimeters, those are units, right? Centimeters. So now what? Well, we want to verify whether this is a local min, a max, or neither. And how are we going to do that? Well, through using our second derivative test. And how will we know whether we have a max, a min, or neither? Well, if our second derivative is positive, that would tell us that we are concave up, therefore we'd have a min. If our second derivative is negative, that would tell us that we are concave down, therefore we have a max. And if our second derivative just happens to be 0, well, that would tell us that our second derivative test failed and we'd have to use our chart test. And we could use our chart test for this, but I find it funner to, even though that's not a word, well, funner to use our second derivative test. So step 4, find the second derivative. So as a double prime, right, that just means the second derivative is equal to, so multiply negative 10,000 by negative 2, so 20,000 plus, well, what is the derivative of 2 pi r? Well, that's just 2 pi. So, and negative 20,000 to the power of negative 3, right? Because negative 2 minus 1, negative 3. All right, so now what? Well, we plug our radius into our second derivative. So say double prime of 11.7 is equal to 20,000. Sorry, I meant to write r to the negative 3 times 11.7 to the negative 3 plus 2 pi. And we could simplify this, right? We can write it as r to the third, but there's really no need for this part of the question. So let's just plug this into our calculators. And if you plug that into your calculator, you should get a value of approximately 18.77. And we don't care about the value, we only care about the sign. And what we notice about this number, well, it is positive, therefore we are concave up. So concave up. And what does that tell us? Well, because this is written in terms of radius and this is our surface area, when our radius, so let's write a statement. So when radius is 11.7 centimeters, our surface area is at a minimum. And the question is not asking us what our surface area is, but for the fun of it, we can solve for our surface area. So how are we going to do that? Well, you just plug this 11.7 back into our surface area equation, either this one or this one, whatever you find easier. And if you put that into your calculator, you should get approximately 1,285 centimeters. So our surface area is at a min. So when our radius is 11.7 centimeters, our surface area is at a min at 1,285 centimeters squared. Again, the question is not asking us for the surface area. I just did that for fun. All right, so let's just make this a little smaller so we have space to do the next step. So let's resize this. All right. So step number 5. Remember, the question is asking us for the dimensions that would use the least amount of material to construct this garbage can. Well, we already have one of the dimensions that would use the least amount of material, right? And that is our radius when our radius is equal to 11.7 centimeters. So what was our other dimension? Well, in the beginning of the video, I labeled our 2 dimensions, so height and radius. And how are we going to find our height? Well, if you remember, we had an equation for height. Height is equal to 5,000 over pi r squared. So our height, and we could write this as a function of r, is equal to 5,000 over pi r squared. So our height at 11.7 centimeters is equal to 5,000 over pi times 11.7. So if we plug that into our calculators, we should get approximately 11.6 centimeters. So let's write a final statement. So therefore, and I'm writing this in blue as our final statement. So therefore, when height equals 11.6 and radius equals 11.7, that will give us least amount of material to construct garbage can with a volume equal to 5,000 centimeters cubed. And if we want to double check whether or not we did everything correct, we can plug our height and our radius back into our original volume equation, so this equation. So let's do that real quick. So pi times our radius. So what was our radius? 11.7 we said. So pi times 11.7 squared times our height, so 11.6. And you should get around 4,989. And of course, it's not equal to 5,000. Why? Well, because we rounded. If we didn't round, we'd get exactly 5,000 centimeters cubed. But that's close enough. That's close enough to verify that we did everything correct. And yeah, and on a note, you may be wondering why this question would be important in the real world. Well, if you want to construct something like a garbage can, you want to use the least amount of material to create it. Why? Because you want to save some money. You don't want to have to spend, like, if you don't want to have to spend like thousands of dollars on materials for something that you can minimize. So, yeah, and yeah, that's the question. It was a pretty straightforward and easy question. I might do a harder question next video. And yeah, thanks for watching.